Hi, my student. We're gonna start a new chapter, which is induction machines, chapter number 3. Three-phase induction motor. So an induction motor or synchronous motor is an AC electrical machine in which the electrical current in the rotor required to produce torque is obtained by electromagnetic induction from the magnetic field of the stator winding. An induction motor can therefore be made without electrical connection to the rotor. So let's talk about the construction here. Construction. Three-phase induction motors consist of two main parts, stator and rotor. The rotor is separated from the stator by a small air gap, which range from 0.4 millimeter to 4 millimeter, depending upon the power of the motor. The parts are discussed below. We'll discuss now the parts of the induction motor. Okay, so stator, it is the stationary part of the motor. It is what? Stationary part of the motor. The stator consists of a steel frame which supports a hollow cylindrical core made up of evenly spaced slots pinched out of the internal circumferences of the eliminations. Okay, this is here, as you can see, this is the stator here. This is the motor stator. Okay, this is stationary part. Now let's talk about the rotor. The rotor is also composed of pinched laminations. There are carefully stacked to create a series of rotor slots to provide space for rotor windings. There are two types of rotor windings. We can highlight here. We have two types of rotor windings. Conventional three-phase windings made of insulated wire, and the next type is squirrel cage winding. These type of windings give rise to two main classes of motors. We have two main classes of the motors: squirrel cage induction motors and wound rotor induction motors. Okay, we'll talk now about discuss each type. The first one is squirrel cage rotor. A squirrel cage rotor, as shown in figure 3.2. This is the squirrel cage. Okay, this is the squirrel cage. Okay, is composed of bar cover. Okay, is composed of of pair cover bars, slightly longer than the rotor, which are pushed into the slots. The opposite ends are welded to two copper end rings so that all the bars are short-circuited together. The entire construction, pairs and end rings, resembles a squirrel cage, from which the name is derived. Okay, so just keep in mind this figure here. This is the squirrel cage rotor. Okay, guys, we can see from the figures here. We have, this is the laminated steel core, and we have what aluminum and rings here. We have also aluminum fan blades for cooling here. This is for cooling, and we have, this is the aluminum conductors. Okay, we don't have here any windings here for square cage, only bars here. The next type here, wound rotor. A phase wound rotor has a 3-phase winding, similar to one of the stator. The winding is uniformly distributed in the slots and is usually connected in Y connection. The terminals are connected to 3 slip rings, which turn with the rotor figure 3.3. The revolving slip rings and associated stationary brushes enable us to connect external resistors in series with the rotor windings. So what is the function of external resistors? Are mainly used during the start-up period under normal running conditions. The 3 brushes are short-circuited. Okay, this is the figure, guys. Here, as you can see here, we have, this is the slip rings here. Okay, 3 slip rings, and we have this external resistors here, as you can see. Okay, and this is the rotor inside. There is a windings. Okay, while square cage only bars, pair of bars. Okay, guys. Applications. The 3-phase induction motors are used for mainly in the industrial applications, like what? Pumps, elevators, hoists, conveyors, frequency converters, and etc. This is some applications of the induction motors. Okay, guys, so this is we have here some question as a review question for this chapter. What are the types of induction motor? What are the applications of the induction motors? So this is the end of this chapter. See you inshallah next in a new chapter. Thank you. Hello my student, we're gonna start with the new chapter. It is chapter 4, synchronous machines. Okay, so the synchronous generators can operate either as a generators or as a motors. When operating as a motor, they are called synchronous motors. Synchronous motors run in synchronism with the revolving field. The speed of rotation is therefore tied to the frequency of the source. Because the frequency is fixed, the motor speed stays constant irrespective of the load or voltage of 3-phase line, hence called constant speed motors. Constructions. Similar to the 3-phase induction motor, synchronous motors also consist of the following main parts. The first part is what here is a stator. the stator of a three-phase synchronous motor called the armature is identical to that of the three-phase induction motor. Okay, figure 4.1, this is the synchronous stator, and when energized from a three-phase supply develop what? A rotating field in the same manner. Okay, coil wound or mounted on the rotor are energized from a DC source to form what? Magnets that locks in synchronism with the poles of opposite polarity produced by what? By rotating flux of the stator. The number of rotor poles is made equal to that of stator poles. The next part is what? Rotor. There are two types of rotor that classify the types of synchronous machines. Cylindrical rotor. This rotor is shown in the figure down here, figure 4.2. This is the cylindrical rotor. It is constructed from a solid steel for high speed operation. Cylindrical motors cannot accelerate high inertia load and are used for other loads with low starting torque requirements. The next type of rotor is what? Silent pool rotor, used for synchronous motors which built for use with high inertia low speed loads. They have many poles projecting radially outward from a steel spider as shown in the figure. Silent pools are bolted or keyed to the spider and the spider is keyed to the shaft. This is the figure, silent pool rotor. Excitations. The poles are excited by DC current. The exciting coils are connected in series to two slip rings, and the DC currents feed into the windings from an external exciter. Slots are also punched out along the circumference of the silent pools. Okay, the output of the exciter can be varied by controlling the small exciting current that follows in the stationary field windings. The synchronous speed of the motor is given by this equation, very important equation. Ns, synchronous speed, equal 120 multiply frequency over number of poles. This is frequency, and this is what, guys? This is number of poles. Principal operation: when a three-phase winding is fed by a three-phase supply, when a magnetic flux of constant magnitude but rotating at synchronous speed is produced. Figure 4.4 show a two-pole stator in which poles are rotating with synchronous speed, say in clockwise direction with the rotor position as shown. Suppose that stator pole are at the instant suit, okay, at point A and B. The two similar poles north and the two similar poles N of rotor and NS of the stator, as well as S and SS, will repel each other, with the result that the rotor tends to rotate in the anti-clockwise direction. This is the synchronous motor principle of operation. Applications: low horsepower, high-speed synchronous motor are used for fans, blowers, compressor pumps. High horsepower, low speed synchronous motor are used for pulp, beater and grinders, line shift, tube, okay, steel and metal rolling mills, rock and or crushers. Okay, here we have some question as a review questions. What is the cylindrical rotor synchronous motor? What is meant by excitation? What are the applications of the synchronous? Okay guys, so try to solve these questions, very important questions. Thank you. Hi my student, we're gonna start with the new chapter, which is chapter 5, single phase motors. Single phase motors, AC motors, are common for industrial as well as commercial and residential usage. They operate from a single phase AC power source. There are three basic types of single phase AC motors. These types are universal motors, induction motors, and the third one is synchronous motors. We'll start with the first one. Universal motors can be powered by either AC or DC power source. The universal motor, illustrated in figure 5.1, is constructed in the same way as a series 1 DC motor. However, it is designed to operate with either AC or DC applied. The series 1 motor is the only type of DC motor that will operate with AC applied. Shunt 1 motors have windings with inductance values that are too high to function with AC applied. However, series motors have windings that have low inductance, a few turns of large diameter wire, and therefore offer a low impedance to the flow of alternating current. The universal motor is one type of AC motor that has concentrated field windings. The field windings are similar to those of all of all DC motors. This is the figure 5.1. We have two diagrams here. This is the schematic diagram. This is the armatures, and this is the field windings in series with the armature. This is to AC or DC power source. This is we can apply the source. Okay. Principle of operation. The operational principle of the universal motor with AC applied involves the instantaneous change of both field and armature polarities. Since the field windings have low inductance, the reversals of field polarities brought about by the changing nature of alternating current also create revolves of current direction through the armature conductors at the proper time intervals. The universal motor operates in the same manner as a series winding DC motor, except that the field polarity and the direction of armature current change at rate of 100 times per second when connected to a 60 Hz source. This is some applications of the universal motor in industry are mainly for portable tools and small motor driven equipment. In home applications include mixer, blenders, electrical drills. Let's come to the next type now. Induction motors. Split phase induction motor. Single phase AC induction motors are shown in figure 5.2. The coil symbols along the stator represent the field coils of an induction motor. These coils are energized by AC source, therefore their instantaneous polarity change 120 times per second when 60 Hz is applied. This is the split phase induction motor. Okay, we have this is the switch here. This is the armature here, and we have auxiliary windings. This is the main windings, and this is the voltage applied here. Single phase induction motors have a solid rotor referred to as square cage rotor. This type of rotor has large diameter copper conductors soldered at each end to a circular connecting plate. This plate actually short-circuited to the individual conductors of this rotor when current flows in the stator windings. A current is induced in the rotor. This current is developed due to transformer action between the stator and rotor. The stator, which has AC voltage applied, acts as a transformer primary. The rotor is similar to a transformer secondary since current is induced into it. Since the stator polarity change in step with the applied AC, it develops a rotating magnetic field. The rotor becomes instantaneously polarized due to the induced current flow through the short-circuited copper conductors. And we have a questions as a review. How the universal motor works. Number 2, what are the applications of the universal motor? Number 3, what is a split phase motor? Okay, this is the end of chapter 5. I'll see you inshallah in a new chapter. Thank you.